Today is May 19th, and we're going to be talking about double angle identities. And these actually all come from the sum angle identity for sine, cosine, and tangent, okay? So sine of 2 theta. Okay, so sine of 2 theta, all right, is really just sine of theta plus theta, okay? And then we could use the sum addition or the sum identity for sine to figure out what this is equal to, because now my alpha is theta and my beta is theta, right? So this is sine of theta, cosine of theta, and then plus, okay, and then cosine of theta, sine of theta. Okay, but right here, it really doesn't matter the order because this means multiplication, cosine theta times sine theta. So it doesn't matter which one we write first. So we can rewrite this and put sine theta first. Okay, so this becomes sine of theta, cosine of theta, and then plus sine of theta, cosine of theta, and then sine theta, cosine theta, plus another sine theta goes, well, we have the same thing here, right? So we have two of them. So sine of 2 theta is 2 sine theta cosine of theta. And I'm going to tell you, this is a really important one. We just used this in calculus this week, okay? So, I mean, it comes back again, okay? So I'm going to put these final ones because I'm just showing you where they're coming from. This is the identity that's on your formula sheet or identity sheet that I gave you with this third packet, okay? All right, so let's go on. Cosine 2 theta, you notice here that there's 3 of them, right? And the reason that there's 3 of them is there's 3 different ones we can do, okay? It's going to be the same idea though, okay? So cosine of 2 theta is really just cosine of theta plus theta, right? Because theta plus theta is 2 theta, okay? So this is cosine of theta times cosine of theta. And remember, it's the opposite, right? So it's going to be minus, and then sine of theta, sine of theta. Well, what's cosine theta times cosine theta? Well, that's really just cosine squared theta. So this is cosine squared theta minus, and sine theta times sine theta is sine squared theta, okay? And this is another one. Of all of these, the one I see most often used is this one though. Okay, that's why I started with that one. Okay, so now there's another way we can do this, okay? So now I know that cosine 2 theta is cosine squared theta minus sine squared theta, but you see squares, right? And what have I always said? You should be thinking about trig identities here, right? Okay, so, or not trig identities, Pythagorean identities, okay? So this cosine squared theta can be replaced, okay? Because cosine squared theta is really 1 minus sine squared theta, okay? And that's what we're going to do. So we have cosine squared theta minus sine squared theta. I know from the Pythagorean identities that I can manipulate it and I could wind up, I can't get the whole thing, but I can replace this one, right? Because this is replaced with, and I'm going to put parentheses around just to emphasize it, okay? You really don't need the parentheses here. And it'd be 1 minus sine squared theta. Because 1 minus sine squared theta is equivalent to this cosine squared theta. I'm going to close the parenthesis and then minus sine squared theta. Okay, so what is this telling me? This is telling me 1 minus sine squared theta minus another sine squared theta, right? Well, that's just 1 minus 2 sine squared theta. And here's the second version that we could use of cosine of 2 theta. Okay. And then this one is, okay, we're going to do the same thing, okay? We're going to use this one to get this one, okay? So cosine squared theta minus sine squared theta. Last time I switched the cosine squared out, but this time I'm going to switch the sine squared out, okay? So cosine squared theta minus, okay, so what is sine squared theta equivalent to? It's equivalent to 1 minus cosine squared theta. And then that would mean cosine squared theta minus 1 plus cosine squared theta. And here we have a cosine squared theta. And here we're adding another cosine squared theta. So that'd be 2 cosine squared theta. So this is 2 cosine squared theta minus 1. And that's the third version of cosine 2 theta that you could use. Okay? All right. I'm going to say this. Tomorrow is going to be half angle identities, okay? And the half angle identities, if we have theta here and we have 2 theta here, okay, this angle right here is half of that one, right? So if this one's theta, this one would have to be half theta. And that's how we come up with the half angle identities, okay? So that's tomorrow, okay? All right, tan 2 theta. Let's slide up to this one, okay? So tan 2 theta. Well, what's tan 2 theta? Well, tan 2 theta is really just tan of, you guessed it, theta plus theta again, right? Okay, and what we had here when we did the sum identity for tangent, it was tan theta plus tan theta over, and it was 1 minus tan theta times tan theta. Well, tan theta plus tan theta is 2 tan theta over, and tan theta times tan theta is tan squared theta. So this is 1 minus tan squared theta. So whenever you see tan 2 theta, you could replace it with 2 tan theta over 1 minus tan squared theta. All right. And that is another identity. Okay. And those are all the identities we're going to use today. Okay. So that's it. Let's go and start doing some problems. Okay, so for example 1, I know that cosine of theta is equal to negative 5 over 13, where pi is less than or equal to theta is less than 3 pi over 2, okay? So our angle theta is between pi and 3 pi over 2, which puts it into the third quadrant, that bottom left quadrant. So I'm going to draw that because I know where my theta is. Okay, so for this, I know because of this right here, this is pi and this is 3 pi over 2, and my angle theta has to be somewhere in between. So I know it's here. Okay, so this angle that I rotated is my angle theta. And I know from this cosine ratio that this x, this horizontal leg, because this is the right triangle here, this horizontal leg is negative 5, and my radius or hypotenuse has to be 13, okay? So I could figure out what this y is right here, right? So I'm going to call it y, okay? One thing I know is y has to be negative, right? Because of where we're drawing this, okay? So I know that negative 5 squared plus y squared is equal to 13 squared. You would need the parentheses around the negative 5. You wouldn't have to put parentheses around the 13. I just did it to be consistent, okay? So this is 25 plus y squared is equal to 169. Subtracting 25 from both sides, that would give me y squared is equal to 144. I'm going to square root both sides. And that would give me the absolute value of y is equal to 12. And then y would equal plus or minus 12. But what do we know? It has to be negative 12, right? So my y is negative 12. Okay, now we're trying to find the sine of 2 theta. And maybe I should have started there, okay? So sine of 2 theta, because you're maybe wondering like, why'd you do all that, okay? Sine of 2 theta from our identities is 2 sine theta cosine of theta, right? So to figure this out, I need cosine of theta. Well, I know that. That's negative 5 over 13. And I need sine theta. Well, I can get that one too, right? Because now I know this y is negative 12. So sine theta is negative 12 over 13, okay? So this is equal to 2 times negative 12 over 13 times cosine theta, which is negative 5 over 13. Okay, and then we're just going to multiply this out. So this is equivalent to 2 times, and negative 12 times negative 5 would be 60, positive 60, over 169, because 13 times 13 is 169. And then 2 times 60 would be 120. So this is 120 over 169. And that's the answer to sine of 2 theta, because that doesn't reduce, okay? All right, that's what sine 2 theta is equal to. It's 120 over 169, okay? All right, let's do another one kind of similar to this. Okay, so for example 2, it's kind of the same thing, okay? So I'm giving you cosine theta. It's 3 square roots of 13 over 13. And you notice like the square root of 13 over 13, right? This has been simplified, okay? So this really came from cosine of theta is equal to 3 over the square root of 13. It'll just be a little bit easier if we work with that number instead of 3 square roots of 13 over 13, okay? Okay, so now I know this too. So my angle theta is between 7 pi over 2 and 4 pi, right? Okay, so that's going to be more than one rotation, all right? And I also know that cosine, I'm trying to find cosine of 2 theta. So I'm going to start with this one, okay? So there are 3 options here, okay? And there's not one that's better than the other necessarily, okay? I'm going to do this one. I'm going to choose cosine 2 theta is equivalent to cosine squared theta minus sine squared theta. Okay. So what I have to do to figure this out is I got to figure out cosine theta and sine theta. I actually already know cosine theta, right? Because it's 3 over square root of 13. What I can do, because I know where theta is, I can use these 2 sides of my triangle to figure out what sine of theta is, okay? So that's what I'm going to do, okay? So I know, I'm going to draw a picture. I know, and I'm going to count by pi over 2s, okay? So I know this is 0 pi over 2. So this is 1 pi over 2, 2 pi over 2, 3 pi over 2, 4 pi over 2, which is the same as 2 pi, 5 pi over 2, 6 pi over 2, 7 pi over 2. So right here is 7 pi over 2. And then I go one more, that's 8 pi over 2. And 8 pi over 2 is really 4 pi. So I'm in between here and here, which puts me in this quadrant, okay? So I'm going to draw my triangle, my terminal side of my angle, right? Because I'm actually going around more than once, right? I'm going all the way. It's like a snail trail, right? Okay, so right there. And what I know is I'm going to draw my right triangle in. Okay, that's my angle theta. I really don't know what it is, but I know that's where it's going to be located, okay? I know my x has to be 3 and my r is the square root of 13. So once again, I got to figure out this y, right? And there is something I know about it. I know my y has to be negative, okay? So 3 squared plus y squared is equal to the square root of 13 squared. So here's an example. I didn't put the parentheses around the 3, right? So 3 squared is 9 plus y squared is equal to 13. That would be y squared is equal to 4, square root both sides, right? That would be the absolute value of y is equal to 2, which means y is equal to plus or minus 2. But we know because of where it's at, y has to be negative 2. Okay? So I know now that this side is negative 2. Okay? So now I can come back over here and figure this out. Okay? So this would be equal to cosine of theta, which is 3 over the square root of 13. So 3 over the square root of 13 squared minus, and then sine theta would be this negative 2 over the square root of 13. So negative 2 over the square root of 13. But I would need to square that too, right? So this is equal to 3 squared, which is 9 over 13 minus negative 2 squared would be 4 over 13. So this comes out to be 5 over 13. Okay, and that's the answer. Okay, so I'm going to show you another way where you really, I didn't want to start with this one, but I'm going to do this a different way. And maybe you said, Mr. Mitchell, why'd you do it that way? Okay, and you had that like little snotty attitude, but that's okay. All right, okay. And so what we could have done is we really didn't need to figure out the sign because we could have used this version of cosine 2 theta. So cosine 2 theta is really 2 cosine squared theta minus 1. And since I already knew cosine theta, I could put it here and I could have figured it out that way. So I'm going to do it this way too, okay? So this would be equal to 2 times cosine theta was 3 over the square root of 13, and I'm going to square it, but then I'm going to have to take 1 away, right? So this would equal 2 times 9 over 13 minus 1, right? And that would give you 18 over 13 minus, and then we need a common denominator. So 1 is 13 over 13. And see what happens. You get the same answer. So, some of you chose to do it this way. Some of you chose it to do this way. I wouldn't, both ways would be right. Okay. It just depends on which way you want to do it. Okay. And you could have done it where you didn't even use cosine, because we could have also done the third way, right? We could have done cosine 2 theta is equal to 1 minus 2 sine squared theta. And then in that case, you would have still had to find sine theta, but you wouldn't have had to use cosine theta at all. Okay. And you would have gotten 5/13 there too. Okay. So I just want to point this out. Like, there's not like, oh, you got to do it Mr. Mitchell's way. No, 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 no. Okay. Whichever way you want to do it. One of those three would work. Okay. Any one of those three. All right, let's go to example number 3. Okay, so this is a solving problem, okay? And we're gonna use these this is kind of where it's used a lot, okay? Is we're gonna use this double angle formula to solve, okay? Now, I'm gonna say something. When you're doing trig functions, you want the same angle type, and then you also want the same trig function, because it's much easier if you have if everything in the equation is the same trig function, like it's all sines or it's all cosines or it's all tangents. Okay. All right. So we want to solve this 3 sine squared theta is equal to negative cosine of 2 theta plus 2. Here's the problem. There's like 3 choices you could use here, right? Okay. But there's a best choice. Okay. Because this is sine squared theta, I could rewrite this one as 1 minus 2 sine squared theta. Okay. And that's what I'm going to want to do. Or another option is move this over and then make that um, make that substitution that I just said, okay? So I'm looking at this, I'm gonna just move it over, okay, first, okay? So this is 3 sine squared theta, and then because I'm gonna move it over, now this is not proving an identity, this is solving. So we know that these are equal, okay? That we're starting out like, if it says solve it, we know these two things are equal. We're just trying to figure out what theta causes this to happen, okay? So this would be plus cosine of 2 theta, and then equals 2. All right. I may or may not in the future need to move that 2 over. Okay. So right here, so I'm going to say this. Okay. So we have 3 choices here. Okay. Because cosine 2 theta is equal to cosine squared theta minus sine squared theta. It's also equal to 2 cosine squared theta minus 1. And it's also equal to 1 minus 2 sine squared theta. Okay. Now, this is the one that deals with sines, right? And it's the only one that deals with just sines. If we make this become this, we're going to have an equation now that only has sine in it. So this is the one that we want to choose and use. Okay. All right. So we're going to take this. This is the same as cosine 2 theta. So we're going to replace this right here with 1 minus 2 sine squared theta. Okay. So we have 3 sine squared theta and then plus 1 minus 2 sine squared theta. And we know that equals 2. Okay. So now, okay, we have 3 of these sine squared thetas, and here we're going to take 2 of those sine squared thetas away. So we'd have just 1 sine squared theta. So we have sine squared theta plus 1 is equal to 2, or sine squared theta is equal to 1. Okay, so now it's our job to get to the trig function, right? So we're going to square root both sides, because that will get rid of the square. Okay, so when you square root a square, you're going to get absolute value. So this is the absolute value of sine of theta. is equal to 1, that would mean sine theta is equal to plus or minus 1. And that would be plus or minus 1 over 1, right? Because this is a ratio. Okay, where does that happen? Okay, so remember, this is our y and this is our r. Where is it that both y and r would both be 1? Where would y and r both be 1? It would happen right here, okay? Because right there, x is 0, y would be 1, and our r would be 1. It won't happen here because our y is 0 there. Will it happen here? Yeah, that's going to be where it's negative, right? Okay, so right here it could happen also. So that would be 0 comma negative 1, right? X is 0, y could be negative 1, and then r would have to be 1. And both these angles, this angle right here and this angle right here, would both give me a ratio of either 1 or negative 1, okay? So that would mean theta, this angle theta, is either equal to pi over 2 or 3 pi over 2. And there's two answers. And I asked you only to do the ones between 0 and 2 pi, right? So only up to right here. Find all the angles up to from here all the way around to here, and that's it, okay? So you didn't have to keep going around. All right? Those are our two answers. All right? Okay, let's go to example number 4. Okay, so for example 4, what we want to do is we want to verify that 2 over tan x times the quantity 1 minus cosine of 2x is equivalent to cotangent x over sine squared x. Okay, so this isn't an equation. We actually want to show that they're the same, right? So we can't move stuff from side to side again. Okay, so all you can do is work on one side and show that it matches the other side. So it's really just simplifying both sides, right? And this is a problem where I'm going to work on both sides, okay? All right, so I'm going to start out. I'm going to switch this tan x to sine x over cosine x, okay? So we're going to have 2, and this is just the choice that I made, okay? There's different choices you could make, all right? So this is sine x over cosine x times 1 minus, okay, now I want to also at the same time switch this cosine of 2x. Now with cosine 2x, there's 3 choices, right? And I'm thinking, and I could be wrong here, okay? But I'm thinking that I want something that just deals with cosine, okay? So we do have one, right? And so that is minus, right? And we're going to swap out this cosine of 2x with 2 cosine squared x minus 1. Close the parenthesis, close the parenthesis. And then this equals, okay? And then on this side, I'm going to change this cotangent x to cosine x over sine x, okay? So cosine x over sine x over sine squared x, okay? I'm going to hold off distributing the sine x over cosine x, okay? So this would be 2 over, and then sine x over cosine of x times, and this would be 1 minus 2 cosine squared x, and then it'd be plus 1, right? Equals, okay? And over here on this side, I'm kind of working on both sides at the same time. I'm going to multiply top and bottom by the sine x to get rid of this complex fraction, okay? So if I multiply this top by sine x and the bottom by sine x, what's going to be left on top is cosine x over sine cubed x. And I'm kind of done with this side, right? There's not really anything else you could do, okay? Okay, so back over here, there is more I can do over here, right? This would be 1 plus 1, okay, which would be 2, right? So I have 2 over sine of x over cosine of x times, and this would be 2 minus 2 cosine squared x equals, and then cosine of x over sine cubed x. Okay, so I'm thinking, okay, what can I do? What can I do? What can I do? Okay, I'm going to distribute here. Okay. And it's kind of like, I kind of am starting to think that we got the right thing because we don't have a 2 over here, which must mean this 2 cancels, right? I mean, that's kind of use this side to kind of lead you to what should be happening, okay? So this would be 2 over, and this would be 2 sine x cosine x. And then minus 2, right? Minus 2. And right here, okay, when I multiply this sine x over cosine x times cosine squared x, I would be left with sine x cosine x equals, and then cosine x over sine cubed x. Let's slide it up a little bit. Okay. All right. So now what I have is a complex fraction, right? Well, actually a complex fraction, but also I can factor a 2 out, right? Let's do that because I can factor out 2 and then they're going to cancel. Okay. So I have 2 over 2 sine x over cosine x. And you know what? I said it and I didn't do it. So I'm going to factor a 2 out of both these terms. So parenthesis. So sine x over cosine x minus sine x cosine x is equal to cosine of x over sine cubed x. So now this 2, because this is a product, 2 times all of this, and this is also a product 2 times 1, right? The 2's are going to cancel, and I'm left with 1 over sine of x over cosine of x minus sine x cosine of x equals cosine of x over sine cubed x. Okay, so now what I'm going to do is I'm going to multiply the top and the bottom by cosine x because I've got a complex fraction. Okay, and what's telling me I'm on the right track? What's telling me I'm on the right track is I'm going to pick up this cosine x in the numerator, right? So if I multiply top and bottom by cosine x, the top is going to become cosine of x. Okay, and now the bottom is going to be sine x. Okay, and because I multiplied this by cosine x, so the cosine x's are going to cancel, but I also need to multiply by cosine x over here. So this would be minus sine x cosine squared x. So minus sine x cosine squared x, right? Equals cosine of x over sine cubed x. Okay, so see how it's starting to reveal itself, right? It's starting to reveal itself. Okay, so what's next? What could I do next? So you're looking at this and going, well, they both have what in common, right? And there's a product here because the sine cubed mean it's a product, right? So we could rewrite, we could factor out a sine x, right? So we'd have cosine of x over, and then sine of x times, and if we factor sine x out of that, we'd be left with a 1 minus cosine squared x equals cosine of x over sine cubed x. That's a Pythagorean identity, isn't it? Right here, 1 minus, yeah, because cosine squared x plus sine squared x is equal to 1. So 1 minus, this is sine squared x, right? So this would be cosine of x over sine of x times sine squared x. It's kind of like a puzzle. You're just, and all of a sudden, it just like, boom, there's the last piece, right? Sine cubed x, right? And then sine x times sine squared x is sine cubed x. And we did it, right? We proved it. Took the whole page, but we proved it, right? We proved that the left side and the right side are equivalent because we didn't move anything from one side to the other. So we just worked on one side and everything was equivalent statements. Okay. And I want you guys to know this. I did not know where we were going to go with this. I mean, sometimes I do these and I kind of like not not practicing them or not going over them before I teach them, because I want you to see that, like, I don't necessarily know exactly where it's all going to go, right? You just jump in, you see one thing you can do, that leads to something else you can do, which leads to something else. And then all of a sudden, it's probably somewhere in the middle, you start to see things starting to appear. Okay. All right. So that's the beauty of verifying these identities, or, it's proving identities. Okay. That's what it's really called. Okay. You're actually writing a proof. You're proving that these two things are equivalent by showing that they turn out to be exactly the same at the very end. Okay, guys, let me get the assignment sheet and I'll tell you what you need to do for today. Okay, guys, what I want you to do today is the double angle identities, and I want you to do worksheet TEI 8. Okay? You guys have a great day. We have 3 more lessons, guys. 3 more lessons. Yay. All right. You guys take care. Bye-bye.